Okay, so I think we might be live, possibly. Let me just check that we are good. All right, so we are. All right. So what I might be doing is I'm going to be sharing my notebook that I'm going to be going through, and you are more than free to ask questions while I'm doing that. So let me just check. So just say ask questions here. Right. Hopefully you can see what I'm typing in the group chat. Yeah, so also in the description, you should be able to see a link to the notebook, right? So when you open that, it's my Google Colab notebook. Make sure you copy it to your drive and then connect it to a session. So actually save it to your own drive and then connect to a session. So let's just see. Let's just see if there are people already before we. Okay. All right, awesome. Okay, so let's give it a few minutes before I start specifically. But what I do want you to do is ask questions while I'm coding. So if there are any specific questions that you want to ask about PyTorch, go ahead and ask. So for this particular lesson, what I'm going to be focusing on is really what PyTorch is all about. I'm not necessarily going to be going through neural networks because neural networks is only part of PyTorch, as you'll see. Of course, it's a big and important part of PyTorch, but that's not the only thing PyTorch can be used for. So for me, the way that I look at it, it can be used as a replacement for NumPy. Yeah. Okay, so let me share my notebook. I'm not sure if other people are going to be joining, but they should be able to see it later on. Yeah. All right, here we go. Okay, so the notebook, if you haven't seen it already, I want you to open the gradient descent notebook and work with me. And from time to time, I'll come back and check for if there are any questions. Yeah, so let's go ahead and import it. And if you haven't done this already, make sure you change your runtime type and make sure it's a GPU, okay? And Python 3, obviously, because you don't really want to be using Python 2 these days. Yeah, so go ahead and import PyTorch. Now, luckily with Google Colab, you don't have to install anything anymore. PyTorch is part of the Google Colab environment, so it's already there. Right, so we're going to import NumPy as well in case we need to use it later on. Matplotlib because we're going to be plotting some of the results, and linear regression because I want to be comparing against the parameters that sklearn will come out of. Yeah, so this thing, the device, it's not too important for our lesson, but I'll just mention it. So just to make sure that CUDA is running, this is how you do. You go torch that device. In brackets CUDA 0. So 0 stands for the GPU. So in this case, we only have one GPU because you can have up to 4, right, in one machine. So if you do have available, otherwise it's going to be a CPU, right? Okay. Right. Any questions so far? No. All right. Let's keep going. All right, so what we're going to be doing is we're going to be creating a synthetic data set, and we're going to be doing linear regression. So I'm not going to be doing stochastic gradient descent. I'm going to be doing gradient descent. Yeah, all right. So I'm going to create 100 data points. And over here, the x value is going to be just a random number between 0 and 5. Okay, so from that, we're going to create y, which is mx plus b, which in this case, m is 5.1, b is 2.3. But as with any any problem, the data that we get is usually going to be noisy, right? So that's why I added this random noise, well, normally distributed random noise, but with a standard deviation of 2. Okay, so if we plot our results, this is what we get. All right, so this is a true function which we don't actually get to observe, so we don't have access to it. And so, yes, the observed one is really what we're going to be doing gradient descent on, not the true y. All right. Just a note. So if you want to be making sure that you can plot it using matplotlib, you have to make it a numpy array. And to make it a numpy array, you go .numpy, and that's it, right? It doesn't work out of PyTorch out of the box, which is, I guess, some is unfortunate, but yeah, this is a caveat that we had to work with right now. Okay, so what we're going to be doing is we're going to, given these observations, we're going to try and estimate. We're going to try and estimate y estimate equals w estimated times x plus b estimated, right? So the question is, how do I get the best possible w and b estimate given, sorry, not the observations, right? So what are the best ones? So we initialize w and b to be random, like normally distributed numbers. But the thing that we're going to be saying is, the important part is that we had to say requires grad equals true. All right, so far, is there any questions? No? Okay. Okay, all right, let's keep going. So, how do we go ahead and find the best estimates for w and b? The way that we do it, we create a loss function, right? So, loss function is something when you continue, as you'll hear over and over again. And yes, so the question is, how do I penalize my estimates so that when you have a bad estimate, you get a large loss function? All right. So in this case, like if you've seen this already, saying, okay, so this hat over here stands for estimated y. If it's further away from my observed y, then penalize it. Okay, so you square it because you want not just the absolute value, but you want to square it. All right, so there's nice gradients. I didn't have to square this. I could have easily just taken like absolute value over here, but anyway, we're just going to take mean squared error instead. Okay, so this is torsion mean. You go square. So this is squared part. So and this is the error. Okay, so y predicted is y I had over here. And if I do that, my loss function in this case, actually, let me just run all of this, which I haven't yet. Delete this one. Yeah, so my loss in this case is 240.88. Now notice how there's this other thing called grad function. And the reason that I even get this is because I've set requires grad equals true. All right, so basically the gradient flows on from my W and my B estimates all the way to Y predicted. So through this error onto the loss. Okay, so see how it says mean backward? And the reason that it says mean backward is because I've set mean over here. Now that's not important to remember, like PyTorch takes care of that all for you, but the main point is that the gradients are there if you need it, all right? Now, if I was to print out my gradient, so what is my gradient at this point? You find that it's none, all right? So in order for PyTorch to calculate these gradients, you have to go L.backward, all right? So when I run this, you end up getting negative 87. Right now, this next point over here, it's really optional. Basically, I'm manually calculating what the gradient is supposed to be. yeah, so if I manually calculate the gradient, this is what I get, right? So here we go. So I have my, you can run through the maths yourself, right? So I'm not going to go through it, but it ends up being error times x multiplied by 2 divided by n. Okay, so I have my error over here, e times x. You take the mean of it and multiply that by 2. And of course, we get negative 87, which is exactly what we have over here. Okay. Yeah. So that's the manual way of calculating gradients. So now that you know that PyTorch gives you the gradients, you can just use that to iteratively calculate the best W and B. All right. So how do we go about doing that? All right. So I'm going to go through 200 steps and update my W and my B estimates. All right. So every time you do that, I have to calculate my loss. All right. So which is what we saw before. We have my Wx plus B. You look at the mean squared error in the second line. You do L dot backward again. Now, this is not important. All I'm saying is I'm saving my gradients. But this part is quite important, right? It's saying with torch.nograd. I'll talk about this nograd thing later, but right now, if you look at this thing, this is just your usual gradient descent equation, right? So you take your, so your new estimate of W is your old minus a learning rate times your gradient, right? Which is exactly what I'm doing over here. So gamma is my learning rate, ws.grad. Okay, so remember PyTorch easily gives you that. And then we say my old value, right? So this is my new value of W. Now, coming back to this torch.nograd thing. So when we do ws.grad, it does give me my my current estimate of the gradient. All right. But the thing is, if I was to, so keep in mind, W estimate has two things that is carrying the actual value of it. And the second thing that is carrying is the gradient of it. All right. So over here, it's going to be questionable if I allow the gradient to flow through. How do I get the gradient to flow through the gradient of itself and update it? Right. So that's why I say no grad. So once we go through this part of the loop, just yeah, let me just do one iteration of this. Okay, so let me just copy everything from here to here. Or actually, let me just stop here. Red. We'll get this thing. Okay, so but after doing this part of the equation, so obviously the gradient is very small, but that's because we did that 200 times already. But now if I go est grad, you find that it's none. Okay, so basically this switches off the gradient. All right, so it allows you to take the existing gradient and keep it, but as soon as you update it, it disappears. All right, and that's what torch.nograd does. It says keep whatever we have existing, but don't allow it to flow on from here. All right, because thing is, like when we're going through this loop, it kind of gets complicated. Not complicated. It's wrong to let the gradient flow through into the new estimate gradient. So the only way that the gradient should flow is through here, is through the loss. Okay, so enough of that. We need to reset the thing to say requires grad equals true. All right. So there's two ways of doing this. So either I say equals true, or I do underscore. So you find that a lot of PyTorch functions, if you want to set it in place, you have the underscore option of doing it rather than saying equals to. Okay, let's see if there's any. If there's any other questions. All right, so there's nothing so far. Okay. And yeah, so that's pretty much it really in terms of how to update the gradients. So let's get rid of all these unnecessary cells. Yes, so once I plot these things out, my losses, and my weights and my B's, you find, okay, so first of all, the loss just dives down to somewhere close to zero. It never gets to zero because remember our observations are noisy. But our W, you'll see that it vibrates until it flattens down onto a certain thing. And same idea with B, all right? And just if you want to look at the last set of W's, you'll find this thing, all right? So at the point that I saved it, it did have a required gradient equals true, but yeah, and last thing, just to compare it to our usual W, the actual W and B that we had. So the true W was 5.1, B was 2.3. So the W estimate that I end up in the end, 4.8, which is close enough, I suppose. And the same way, B's with that, yeah, so 2.9, and the actual one was 2.3. Okay, so that's really because of this of the noisy observations that it got that thing. So that's pretty much it for this tutorial. So this was very much a introduction to PyTorch, not necessarily the neural networks, but just notice how a lot of that had similarities to NumPy, right? So for example, even getting the random numbers. Now, if I was doing this in NumPy, I think I would go numpy.random.rand, right? So instead you go torch.rand. The best part about PyTorch is that all you have to do is requires gradient equals true to start doing automatic differentiation. Now, when you're doing now, if you've seen Keras or TensorFlow, you would go, hey, hang on, this is actually hard. You don't there's a lot less steps to do, which is exactly true, right? So when you're doing neural networks with PyTorch, you probably don't want to be doing it this way, okay? So let me just quickly show you a preview of what I will be doing in a few weeks' time, which is the MNIST example. Let me just zoom out so you can see. So yeah, so there's pants, dresses, stuff like that, instead of the written MNIST thing. But if you're aware of Keras, you can define your model like this. All right, so it's a 28 by 28 image, but you go flatten, and then you have a linear layer, so which is the same as saying dense in Keras, right? And then you go ReLU, and then you add the softmax, right? So, and the last thing in NumPy, you're probably used to saying axis equals -1. In PyTorch, you say dim equals -1. All right, so yeah. Now I'm not gonna I haven't finished this tutorial, so this is probably going to be in the next few weeks. But if you're interested in doing this, please subscribe to my channel, and we will be going through this in a few weeks' time. Now let's see if there are any final questions about this. No, doesn't look like it. All right, so I think I might just stop it there. If you have any questions or comments, please do let me know. But otherwise, thanks for watching. And again, subscribe, like the video, and also maybe join the group. All right, there is one question. Let's see. Right. Okay, that's a good question. So why am I a big fan of PyTorch? Look, the biggest reason that I like PyTorch is that I can debug, right? So when I do very complicated models, it takes me, I had to do, when I was using TensorFlow, I had to go TFL run the session and then find my gradients, and then just anyway, I couldn't debug like I would over here. Like for example, I can't, let's see, somewhere, say there, I can easily just go import PDB, pdb.setTrace. Now, I'm well aware that the new version of TensorFlow, and actually even the last few versions, there was TensorFlow Eager, which allowed you to do similar things. But I feel like it's PyTorch is a bit more advanced. Well, to be fair, I haven't tried TensorFlow Eager, right? But I've also been doing the Fast AI course, and that's using PyTorch. So I trust Jeremy Howard's judgment when he says that the PyTorch is a really good thing to be using. Yeah, so anyways, let me just exit out of this. So for me, debugging is really the main reason that I use PyTorch over TensorFlow. And even when it comes to production, there are tools out there where you can push all these models into production. So there is that. Okay, so I think if there aren't any other questions, I will stop it there. Thanks for watching again. Thanks for joining, and I'll see you next time. Bye-bye.